Welcome to Operations on Complex Numbers. As a reminder, a complex number is a number of the form a plus bi, where a is called the real part and bi is called the imaginary part. Sometimes a number will not have a real part. In that case, you will say that the real part is a 0. So for example, for a number 7 plus square root of negative 16, you will first simplify the square root of negative 16 to a 4i. So the number becomes 7 plus 4i. Here, 7 is the real part and 4i is the imaginary part. For a number negative 4 minus square root of negative 49, you will first simplify each of the square roots. Square root of negative 4 is positive 2i, and square root of negative 49 is 7i, and then you will bring down the minus. Here, you will treat these two as if you would like terms. 2i minus 7i is negative 5i, which is your final answer. When it comes to complex numbers, you can perform the exact same operations on those as you would on real numbers. Those include addition, subtraction, multiplication, and division of complex numbers. So let's go ahead and look at the addition example. This question is asking you to add two complex numbers, and all you have to do is add or combine their real parts. 8 and negative 1 is a 7. And then you also combine their imaginary parts. 8i and 5i will make you a positive 13i. And this is the new complex number that you obtained with the real part of 7 and the imaginary part of 13i. The next question will ask you to subtract. Before you start subtracting in this example, you need to simplify the two parts with the square roots. Square root of negative 81 is going to turn into a 9i, and square root of negative 100 will become a 10i. So this is the new problem where I replace each of the highlighted square roots with the simplified versions. Now we will be doing the same thing we did in the addition question. The only thing you need to keep in mind is that before you start combining the real parts and the imaginary parts, you will need to distribute this negative sign that is affecting both terms on the inside of the second complex number. So this negative will make your 11 negative, and it will also make your 10i positive. So I will rewrite this problem without any parentheses, and then we will be able to combine like terms. Two real parts, negative 6 and negative 11, combine to negative 17. And the two imaginary parts, positive 9i and positive 10i, combine to positive 19i. The next question will ask you to multiply two complex numbers, but before I show you the example, I need to introduce you to the new formula. In my write-up, I mentioned that I is nothing but the square root of a negative 1. What happens if you take this little equation and square the left side and square the right side? Well, on the left side, you will end up with I squared. On the right side, your square root and your square cancel each other out, leaving you with negative 1. This formula is important for multiplication and division of complex numbers because you will see I squared in those questions a lot, and anytime you see I squared, you will be replacing it with negative 1. Here's the multiplication example. In this example, you're asked to multiply a complex number that doesn't have a real part, a negative 2i, by a similar complex number 8i. To multiply these two, you will multiply negative 2 by 8, which will make you a negative 16. And you will also multiply an I by an I, and I times I is I squared. Going back to the formula above, I squared will always need to be replaced with -1. So this question becomes -16 times -1, which is +16. Here's another example of multiplication. Here you will be distributing -3i first into the -5 and second into the 8i. -3i times -5 will become a +15i. And -3i times +8i is -24i squared. Here you see I squared appearing once, and that I squared will need to be replaced with -1. Not the regular I, only the I squared gets replaced with the -1. So here you have 15i minus 24 times -1. -24 times -1 becomes a +24. 15i plus 24 is your answer. However, it is preferred that the real part, your +24, comes before your imaginary part in a complex number. So go ahead and switch them places. So put the 24 first and 15i second. This is your final answer. This question here is asking you to multiply a complex number by itself. 6 minus 5i times itself. We'll go ahead and take the 6 and distribute it into the second binomial first. We will then repeat this work with -5i. Notice that the two -30s each has an I in the middle can be combined to a -60i. Now notice that I squared should become a -1. 25 times -1 is -25. Finally, 36 minus 25 is a +5, so here is your final answer. These two questions are my last two examples, and each one of them will ask you to divide a complex number by a complex number. I want you to distinguish between these two problems. The first problem has a complex number without the real part at the bottom of the fraction. The second problem has the full complex number with the real part and the imaginary part. You will be dividing them in a different way. The first example, where you have a monomial, so to speak, in the denominator, just the imaginary part, requires you to multiply the top and the bottom by a single I. The second problem, where you have a real part and the imaginary part, requires you to multiply the top and the bottom by the conjugate of the denominator. Let's look at how multiplying the top and the bottom by I will work for our first question. On the top, you will be distributing your I into the binomial, and that will result in -3i minus 1i squared. On the bottom, 4i times I is 4i squared. Each of the I squareds will not cancel, but will become a -1. Here you will have a -1, and here you will have a -1. I'm going to go ahead and multiply -1 by 1 and 4 by -1. And finally, to write the answer, you will separate the real part on the top over the denominator. So your real part of the answer will be 1 over -4, or just -1/4. And the imaginary part of your answer, so 3i over -4, or just -3/4 I. Now I will show you how to perform the division for number 2 And that is where you have to multiply the top and the bottom by the conjugate of the denominator. Our denominator here is negative 6 plus 3i, so the conjugate is negative 6 minus 3i. I will do it on the next screen. So as you see in black here, I have my original problem. I did go ahead and place the top and the bottom in a separate set of parentheses, and I went ahead and multiplied the top and the bottom by the same thing that I had in the denominator, but with the changed sign in the middle, and that's called the conjugate. It's double distribution on the top and on the bottom, so I will first distribute the 6. I will then distribute the negative I. Now I will do the exact same thing at the bottom. Let's go ahead and combine like terms that I see on the top, this negative 18i and positive 6i, and on the bottom, positive 18i and negative 18i. Those two will actually cancel each other out. Now I will take care of every I squared that I see and replace those with negative ones. Now I will perform this multiplication, which will result in negative 3, and this multiplication, which will result in positive 9. Finally, let's go ahead and combine like terms. Negative 36 and negative 3 will become a negative 39, and 36 plus 9 in the denominator will become a 45. Now I will separate the real part that I see on the top and place it over this denominator, and I will do the exact same thing with the imaginary part. Each of these fractions can actually be simplified. 39 and 45 are both divisible by 3, so I will go ahead and divide. That will make me a negative 13 over 15. 12 and 45 are also both divisible by 3. So 12 divided by 3 is a 4, and 45 divided by 3 is a 15. And that part does have an I. This is your final answer.